Hi guys, it's Friday and hopefully you did okay with the t-test yesterday. And now today you're going to be learning one more test. This time we're going to switch to proportion. So we're in section 2 of chapter 12 and you've done tests about means so far. We did the z-test and the t-test. Now we're going to do the test about a population proportion. Okay, so some of this is going to look awfully familiar because we did confidence intervals for proportions. And so a lot of the formula and stuff look the same. Okay. So here's what you're going to be doing is a one proportion z-test. And so remember in your plan that when you figure out that it is a z-test on proportions, significance test on on a proportion of the population, then that's when you're going to make sure to list one proportion z-test. Okay. Remember that P is our true proportion of the population. And so our HO, our null hypothesis, is going to just start off as P equals the proportion equals the population proportion is whatever your claim is. It's no different than what the claim is stating. Then your HAs are, of course, going to be greater than, less than, or not equal to your one tails or your two tails based on the context of the problem. Okay. Just like means, we've got to run our three conditions. And if you recall, these are the same conditions from the confidence interval. So of course, our most important condition is that it must be random. But now remember, and we keep hammering this, normal is not CLT for proportions. That's only for means. So you have to go back to the NP and the N times 1 minus P being greater than 10 in order for you to show normality, assume normality of the data. And then, of course, independence, same thing, 10N is less than the population. So these look pretty familiar to you. Same exact conditions for the confidence interval for proportions. Okay. Now, our Z statistic should look pretty similar to you as well as when we did the confidence interval. The only difference now is that you see here that we have P hat minus P null. Okay, that P null, because remember, we're taking it from our null hypothesis. And then the denominator, we're not using P hat, we're using P null. This is where students get confused. So please note that you're taking the P from the null hypothesis in this Z statistic. Okay. P hat is used at the numerator only when you're subtracting P null from it. So this will give you your P value, which will then give you a way to write your conclusion. So everything's the same. Nothing's different. It's just now you're taking that statistic to a p-value using your p-nulls instead. Okay, so this should not be too scary. Looks the same, right? There you go. That's your p of your null hypothesis. So then your sketch that you have to do for each of these, your p-null is going to go in the center, that p proportion that is claimed in the null hypothesis. And then you're going to place your p hat that you're testing it against, and whatever it is, one-tailed, two-tailed, left or right, shade in and indicate what your p-value is. Now remember, you always have to mark off your standard error or that standard deviation of the sampling distribution, which is up there for you to see, p null times 1 minus p null over n, and then square rooted. Okay, again, that's nothing new. We did that for our confidence intervals as well. Oops, sorry. I can get this back. There we go. So let's look at an example. Okay. The college has published that 10% of its graduate students are looking for housing. 481 graduate students are randomly chosen. There's your N. 62 are looking for housing. Is there statistical evidence to believe the percentage is higher than the college actually believes? Okay. Now we're looking at this and we're going, I have 10%. Oh, that's a proportion. Okay. My P is 0.10, right? Well, how do I get my P hat? Okay. You're going to have to do a little math. Don't be afraid of that. It's AP stats. So you're going to do hopefully 62 out of 481 to find your P hat. So your P is your true proportion of grad students looking for housing. So in our state, remember, we have to state our parameter and our population. And there it is. You also need to state your hypotheses. So P is 0.1. We're looking to see if it's actually higher than that. And so we're going to put greater than 0.1. And as before with means, if an alpha level, significance level is not given, then you make it 0.05. That's the default. Okay, so we've got our state. And now we're going to go to our plan. We're going to be doing a one proportion Z test. Okay, so you're going to do for proportions. So here's a SRS given in the problem, right? They said they randomly chose them. Now we got to run our normality test. And so we're going to take N times P null. Notice we're using P null. And N times 1 minus P null. And both of those are bigger than 10. So we may proceed with that. And then independent, we're assuming that there's more than 4,810 graduate students at that college. Now, that may not be true. You might want to jot that down in your plan if you're not sure. That might be something to proceed with caution about, because that's an awful lot of graduate students at one college. I don't know. They could have it. They may not. Okay. Now we also need to find our p-hat, as I just mentioned earlier. So 62 out of 481 is that 0.129 for p-hat. Okay. So continuing with this, we go to our z statistic. There's your p-hat minus p-null, and then your standard error in the denominator, which you do need to calculate so you can sketch it. I got 2.12 going to the z table. That goes to 0.9830. We're doing a greater than test, so I'm sure you know what has to happen next. We're going to subtract that from 1, and so our p-value is 0.017. Just like for the mean test, you're going to now compare that p-value to your alpha and write your conclusion. So since our p-value is so low, 0.017 is less than 0.05, there is enough evidence at the 5% level to reject HO. And then remember to stick in your context and conclude there are more than 10% of graduate students needing housing. So we had significant evidence there to reject that college's claim and say, whoa, there's more. And that's pretty important for that college to know, because they have a need for more housing. And of course, I didn't do it here, but you would then create your sketch as described in the previous slide. Okay. Before I close this video, I wanted to give you help on a couple of your homework problems because they were a little bit tricky. I've got this in your Google Classroom, so when you get home to do your homework, you can look at this again. But this is something I'm going to show you what you're to do on 24, and then I'm going to do another one with you too. So the claim is that 73% of first-year college students say well off is an important goal. And then you get an SRS of 200, and out of 132 of those say that goal is important. Okay, so here's your P and your p-hat that you've calculated. So on the left side, you could see you're to run a hypothesis test, which I did. Okay, ran the hypothesis testing. It's a two-tailed test, so that tells you what else we can look at. Hint, hint, we'll look at that next. And we get a p-value of 0.0264. So obviously we're going to reject HO at that level and say that P is not likely 73%. Okay. It asks you in the homework to compare that to, yep, you got it, the confidence interval comparable 95% to the alpha 05. So going back to your confidence interval, here's what the formula was. Now this is where the formulas are different, and I need to point this out. Notice the hypothesis testing uses P null, whereas your confidence interval uses p-hat. There is no p-null in your confidence. You don't have a null hypothesis for a confidence interval. So there's no such thing as that. So you have to estimate with your p-hat that you got from your sample, okay? And that's why that is different in the confidence interval. This is a number one spot for confusion and errors. So please notice, I made this slide specifically so you could see the difference. Look at the formula for hypothesis testing versus confidence interval and be careful. Your confidence interval now uses p-hat at 0.66 over there. And the same thing happens though. You get